So now that we've seen that the original sprite class that we've written in this XNA volume will be, well, basically redesigned for the use with SpaceFighter, where we're going to take that sprite class and break it down into two new classes. We're going to have our SpriteSheet class and our new sprite class. In this video, we're going to be creating the new SpriteSheet class. Okay?
Well, to get started, the SpriteSheet class is what we're considering as part of the engine section. So I'll begin with the engine folder, and this is where we'll add our new item. This, of course, is going to be called SpriteSheet. And inside of SpriteSheet, once again, just to reiterate, the purpose of this class specifically is going to be the central loading point of an actual SpriteSheet graphic, and it will contain all of the information necessary to describe that graphic as a SpriteSheet. So tiles, dimensions, how the frame rate should work, how the animation should work. And then this can in turn be leveraged by every sprite instance, but that'll be when we get into the sprite class.
Exactly.
Now, to get started with, I'm going to begin with the using statements. I'm going to pull out the using for system.txt because we won't be using it. I'm going to add in using statements, and these will be for certain XNA subsystems. More specifically, we'll be looking at graphics and content. So I'll be using Microsoft.XNA. Let me grab some spelling on Microsoft.
Oh, your spelling was so slick in that particular case, it actually looked right to me.
But we're looking for Microsoft.xna.framework.graphics. We're also going to be utilizing some types found within the content namespace also, because again, we're going to have SpriteSheet manage all of the instances of SpriteSheet such that we can set the asset name prior to running load content. So we're going to be, when we go to run load content, we'll need access to a content manager and the necessary types. Now, moving our focus down to the class itself, but before we begin the class, I'm going to establish the SpriteSheet mode enumeration. Again, this simply being a type which more verbosely describes the difference between normal and no damage texture. This way we can optimize our setup by having certain things that do not take damage, not have a texture data associated with those. So,
yeah, no reason to create damage information
for, say, an explosion. Why would an explosion effect need to contain damage information when an explosion can't be damaged?
Exactly.
All right, this enumeration is going to need a name, and that name will be SpriteSheet mode. SpriteSheet mode is going to have two elements. They will be normal and no damage texture. I'm going to explicitly specify the values where normal is set to a value of 0, and no damage texture is going to be set to a value of 1. And with that, I think we're now ready to move into SpriteSheet. The first field of SpriteSheet is going to be the static list that will allow us to manage all instances that are in existence. This will be a public static field. And catch a little bit of spelling on static. It will, of course, be of type list, and the type of the list is going to be SpriteSheet. The name is simply going to be SpriteSheets. And I will go ahead and initialize it using a field initializer. So we will set it equal to new list of type SpriteSheet. And that takes care of our sprite sheets.
All right, from here, Logan's going to begin adding in a lot of the private fields that we're going to have. Keep in mind, most of these you've already seen.
Exactly. What we're talking about here is these fields describing a sprite sheet were first covered in the original animated sprite class. Things like dimensions, the width of a tile, how many frames, and so on.
Exactly.
Though we are going to be beginning with a new one for SpriteSheet, and that is the asset name. Now, all of these set of fields here are going to be private, and just for the sake of time in the video, I'm actually going to omit the modifier private, just because we know that if we omit that, then the fields will in fact be private. So I'm going to begin with the asset name. This is going to be a string field, and the name is simply asset name. Moving on from here, we need fields to describe the dimensions of the sprite sheet, tiles X and tiles Y. Both of these are integers. Tiles Y. The next two fields are going to be used to describe the size of an individual cell. They'll be called tile width and tile height, meaning the width and the height of one tile. So these are integers tile width and tile height. Also, just to throw this out, these are the actual fields that are going to be leveraged later in Sprite to be able to gain a width and a height if you look at this scenario from the sprite level. Because once you're looking at the sprite as being animated and you now want to see this animated object's dimensions, when you look into the data, it will actually be an individual tile width and height, since all tiles within the sheet are the same size. Alright, a few more fields. We now need some information to hold how the timing should work, how the speed of the animation should work. So this is going to be the frame count and the frame interval. We'll have an integer for frame count, and also the purpose of frame count is, of course, to be able to use a number of tiles that is fewer than possible in the overall sheet. What if we had a scenario where we wanted an odd number of tiles to complete a given animation? We don't want to have to be forced to use the entire grid of tiles. And let's see, one more field. This will be a double, and we're going to use this to hold the frame interval, or the amount of time that must pass before frames advance. So frame interval. And while it might sound a little bit strange to have this stored on the overall sprite sheet instead of on a sprite, the reason is this can be looked at as the frame rate. It does seem to make sense to say, all right, this sprite sheet should animate at X frames a second, say 15 frames a second. And really, interval is used instead of frame rate simply because on our side as the programmer, interval is easier to deal with. When someone's using the code and making sprites, frame rate is easier to think about and deal with. So this is just the internal value used to hold a more convenient version of frame rate.
Okay.
All right, two more private fields that we'll need to store for the state of a sprite sheet, and that is the sprite sheet mode and the textures array. The sprite sheet mode is, of course, going to be of type sprite sheet mode, and we'll store that internally as mode. Again, this being stored so that later in time when load content is called and run on a sprite sheet, we know which mode we were created as. And finally, we need our textures array. I'll make this a texture2D array, which I will call textures. And again, the reason that this is an array is so that we can hold multiple versions of the same sprite sheet, where one could be the normal version and one could be the damaged version to show the damage effect. Now, with these fields in place, we can turn around and add some public properties. The reason for these public properties is to give read-only access to certain fields. And the reason that I'm being more careful with the way these fields are accessed is because, or to counter this, in times past I would often make a field directly public. The reason being is it would be very convenient to be able to change that field.
Sure.
Here in SpriteSheet, all of these values are very closely related, meaning the dimensions, the width and the height of tiles, the number of frames is all highly dependent on each other and on the texture that you're currently using.
Yeah, a lot of this is going to get set on instantiation of this class, and then to go in later on and just to change one of these values would break everything.
Right, that means if you were to change any individual value by itself, the only thing that you could do would be break it.
That's right.
So we're simply going to protect access to those because those really are things that have no useful use when they're exposed.
And this is truly an excellent example of where you'd want to create a property that was read-only.
And then the reason for the properties is while changing them is bad, being able to read from them is necessary. We just need to be able to query information from a sprite sheet to know what its dimensions are, how is a sprite going to use it to animate.
Precisely.
So we're going to expose those through public but read-only properties. And we'll begin with tiles x. We'll make a public integer property called tiles x, and of course that's going to be referencing the tiles x field. Now there's going to be a series of these read-only properties, and in the end I'm going to have each one declared on one line. I'm going to move all the brackets up so it takes only one line per declaration. Except for the first one, I'm going to type it out on multiple lines just to make it visually easier to see how the brackets align. Once I get it typed, I'll then collapse it back down to one line. The tiles x property, again, is simply going to be an accessor to the field tiles x. So its get accessor is going to return, that was a great spelling of return. It's going to return the value of this instance dot tiles x. And we can wrap up the brackets for the get accessor. Now, like I was saying, since we're going to have several of these, it saves space. It's easier to read if we actually drop these all into one line. So I'm simply going to pull out some of the space here between the brackets and the identifier until all of this is on a single line.
And we'll space it out a little.
Space it out for readability.
Yeah.
And there we go.
Looks great.
Now, there are three more fields that are also integers. So I'm going to copy and paste a few more times just to get a few duplicates. And one more time. That gives us 3 additional. These are going to be fields for tile width, tile height, and frame count. You will note that I'm going to be omitting tiles Y. And the reason for this is, actually, if you remember back to Sprite, once we got into some of the later videos covering Sprite, we noted that the tiles Y was not actually used anywhere in any of the animation code. I am specifically storing it as a field here because tile width and height is not going to be gathered until a texture is set. That means we do need to remember this value until we have a real actual texture to work with. We won't, however, be exposing it as a property because we don't need it for animation purposes. Now, to get to the fields that we do need, we'll begin with tile width. Tile width is, of course, a simple accessor to the field tile width. Moving on from here, we have tile height as an accessor to the tile height field. And we have the frame count. Frame count property will access the frame count field. And I think that takes care of our integer properties. There's a few more properties we need to cover, but these are things like the frame interval and the textures array. So we'll make, really I think we could still save time if we use copy paste. We just need to remember to start changing the type over. This is going to be of type double, and it is representing our frame interval. And once again, we simply look up a specific field. In this case, frame interval. And we can go ahead and grab one more copy of a property line, this time giving a type of texture 2D array and calling the name textures. And textures is simply going to be an accessor to the textures field. And with those lines, I think that wraps up the properties that we need in place for SpriteSheet, and from here we can move on to the constructor. We're going to set up the public constructor to take in all necessary parameters to initialize the state of this sprite instance. So we're actually going to begin with a constructor that takes in 6 overall parameters. Let me drop this in and we can walk through them one by one. So this is going to be the public constructor for SpriteSheet, and it will need to take in the following. We'll be taking in a string for asset name. We'll be taking in an integer for tiles X, an integer for tiles Y, a double for frame rate, an integer for frame count, and a SpriteSheet mode so that we're able to pass in the type of mode that this SpriteSheet should use. We'll simply call this mode. And with these parameters, we can now begin to set up the state of the current SpriteSheet. Though before we jump into state, I also want to make sure that this new instance of SpriteSheet gets added to our static list. So we'll begin with a line where we take our sprite sheets and we add this new instance into it. So moving on from here, now we can begin on the state of the specific SpriteSheet. I'm going to begin by initializing the textures array. So we'll take this.textures and set it equal to a new texture2D array for 2 elements. We'll go ahead and block in the 2 elements. Even though we may not necessarily be having a damaged texture, I'm simply leaving that slot open. It makes it much easier to loop over the array, being able to rely on the number of elements there. Alright, moving on from here, we need to start storing some of the parameters in the state of this SpriteSheet. And we'll begin with asset name. So we'll take this dot asset name, as of course set to the asset name parameter. We'll be taking tiles X and setting that equal to the tiles X parameter. We'll do the same for tiles Y and for frame count. So again, this frame count will simply be set to the parameter which is passed in. This brings us down to frame interval. And frame interval is going to need to be derived from frame rate. And we'll do that by taking this dot frame interval, setting it equal to 1 divided by the given frame rate. And once again, this same setup was discussed when we were first making the animated sprite class. So again, simply doing a conversion so we can convert frame rate over to frame interval.
Yeah, I mean, it makes sense just looking at it. You get a established frame rate, and we need to find out what our interval is going to be for each frame.
And with that, okay, there's one more field we need to address, and that is the mode. We do need to store the SpriteSheet mode that we're going to be using for later when set texture and load content are called, so that we'll know whether or not we need to generate a damaged texture.
Except we might want to assign it.
That might be a good idea. I'm not sure the compiler would be entirely happy with us using that as a statement. But yes, we will indeed be setting that to the given mode passed in via parameter. Alright, now that we have a constructor set up, I want to go a little bit further with the constructor. Since there are quite a few parameters given, it would be nice if we make this a little bit more user-friendly so that some things, some things can be optional. Frame count might not be relevant if you just design all of your graphics to always use all grid cells. And SpriteSheet mode, oh wow, look at that.
I grabbed sort mode.
I grabbed a type, because we are using graphics, so we're actually looking at the type generally used for sprite batch.
I didn't even see that get thrown up there. Nice.
So pardon me for just a moment while I switch this over to our defined SpriteSheet mode. Again, that enumeration we had declared earlier.
Good catch.
So it's good we're going over this. Now we have fewer errors. But again, there's a lot of parameters here, and it would make it more convenient if we could omit these in alternate constructors. Because if we're using all the grid cells, frame rate can be derived by the tiles X and tiles Y values. And we could say SpriteSheet mode could simply default to normal unless otherwise specified. So let's set up a few extra additional constructors. Now to begin with, since I'm always going to require asset name tiles X, tiles Y, and frame rate to be present, I'll actually begin with these parameters and copy the signature of the SpriteSheet constructor, and that'll give us a good starting point. So what if we wanted to specify just that? We'll end off at frame rate, and we'll chain this constructor to the current constructor, this SpriteSheet. And for the first set of parameters, we can simply pass through the given ones from this constructor. That means as we pass asset name, that is just the asset name that we're seeing. And then the same for tiles X, tiles Y, and frame rate. Now, when we get into things like frame count, we're talking about deriving that from tiles X and tiles Y. We can simply multiply tiles X by tiles Y, and we should arrive at a number of frames which will use the entire grid SpriteSheet. And we had discussed using SpriteSheet mode as defaulting to normal. So that way, if not specified, SpriteSheet mode simply gives a SpriteSheet mode of normal. For the extra code, or for the body of this constructor, I'm just going to leave blank brackets.
Okay.
Because again, the whole point of this was just to chain over to our main constructor. Now, one more copy of this that I'd like to put in place would be the exact same thing, except a scenario that would allow us to specify a SpriteSheet mode. So we'll extend the method signature here to require that a SpriteSheet mode be passed in. And we'll pass that in as mode. Again, the reason for this version of the constructor is if we wanted to specify a different SpriteSheet mode but did not want to specify a frame count. So we're giving a SpriteSheet mode parameter. We'll pass that through here as mode, but we'll still automatically derive the frame count. Now, with all of these in place, I would like to go ahead and build the class and make sure that we have no syntax errors. And what do we have here? SpriteSheet mode. And I think that setting of sprite sort mode might have actually been an error from even earlier. If we look back to the field, it appears that I wasn't watching close enough because we have our mode defined as sprite sort mode. We actually want sprite sheet mode so that we're looking at in the enumeration, not the graphical mode. But now if we build, that takes care of all of our syntax errors. So we have all of the constructors and fields in place for SpriteSheet. Now just a few more things we need to address, and that is the manner in which the texture itself gets set. This is going to be a series of calls beginning with load content, which is in turn going to call set texture, where set texture takes into account the current texture. It will set up the tile width and tile height fields. You will note that in the constructor here, we have set up tiles X and Y, and we have not yet set up tile width and height. This is because tile width and height is going to depend on the final texture's dimensions. So let's move into the set texture method. I'm going to make this method private because once again, set texture is only going to change the texture itself, and that texture is only going to be relevant for the set of parameters that we had set up originally. So I'm going to leave that be something set internally. So this method will be void set texture, and we're going to take in two things: an actual texture 2D to set, and we're also going to take in a graphics device. The reason that we're going to be taking in a graphics device is because later we will need to build the damage texture at this point, after the call to set texture. And in building that texture, we'll need access to the graphics device. So here it is simply acting as a pass-through. But beginning with the parameters here, we're going to take in a texture 2D parameter called texture, and a graphics device. We'll simply call that graphics device. So we'll block in this method, and we can begin with a few lines of code. The first thing we need to do is to take our first element in the textures array and set that. So we'll take this dot textures sub-0, and that will be equal to the given texture. That is the texture passed in via the parameter.
You go ahead and throw a T in texture real quick.
And TEX, grab some spelling,
Excellent.
and that will make that work better. The other thing we need to do is we can now initialize and store tile width and tile height. We now have a texture, and that means we have dimensions to work with. So we'll begin with tile width, the field, this dot tile width. That is going to be, of course, the width of a single cell, and we can get that by dividing the entire width of the texture against the number of tiles in this axis. So tile width will be the overall texture's width divided by tiles x. So now that we know the texture, we can say texture dot width divided by tiles x. So if, for example, we had a texture that had a width of 100, and we had specified that there were going to be 10 tiles in X, we would arrive at a tile width value of 10 pixels for that tile.
Now, for those of you that were just hollering at the screen, I was just going to let Logan finish that line before I asked him to add the other T in up here.
Textures. I wonder what's... Oh, that's actually another misspelling. I was wondering why IntelliSense was being so friendly.
Oh, yeah, there it is.
With allowing me to misspell that. And that is, in fact, because it was spelled wrong here. So if you've been screaming at your monitor, you have probably been screaming at your monitor for a good deal of time by now. But yes, let's get that spelling corrected here.
Fixed everywhere it's at, yeah.
And down here. As a matter of fact, let me undo that, because at the moment I think it still builds, which means it would be easier to simply refactor this, since that's an accepted label. We could take textures and replace it with the proper spelling, textures, hit OK, and here are all the misspellings.
Yay.
Apply to fix.
Nice.
And now everything is happy. So, one last line, and that is, now that we have tile width initialized, we need to do the same thing for tile height. Tile height is going to be the result of texture.height divided by tiles in Y. And for now, that is going to wrap up the set texture method. Again, there will be more to add to this chain of calls when we get damage textures in place, because we'll, after this, need to, or during this, need to assemble a damage texture, but we're not worried about those just yet. What we do need to put in place now is the call to load content, because set texture is really just a halfway method. What will happen is during the load content phase of the game, load content method inside of game 1 will in turn call load content for the overall sprite sheet, the sprite tracking system that's based in that static list. And it'll be this function's job to go through and look through all instances of sprite sheet then call upon the content manager to change the asset name, given here as a string, over into an actual loaded texture and pass that along through setTexture. So let's get this method in place so that everything can be hooked up. This is going to be a public method. It's also going to be static, and it will have no return, so we'll specify this as void, and the name of the method is load content. Now we're going to take in two things here. We're going to take in a content manager and a graphics device. The reason we're taking in a content manager is that's what is going to allow us to resolve the asset name, much like if you were actually in the game's load content section, where, as a matter of fact, that's the actual content manager that will be passed in. It's just the same one that the game is using. So this will be our content manager. We'll simply call this content. We'll also pass in a graphics device, and this is simply to maintain a reference to the graphics device until we get into make damage texture. We're actually being passed in from load content, which will in turn pass it to setTexture, which once we have the damage texture creation code, that will be the one that actually uses the graphics device. This is just maintaining it in a chain of pass-throughs. But the parameter itself is of course going to be of type graphics device, and we can call it, well, graphics device. And now we can go ahead and block this in. And inside of load content, we now need to loop through all existing instances of SpriteSheet. And I'll do that with a for each loop. I'll go ahead and grab the code completion template for this so that I can jump into the type. As we loop through here, each individual variable type will be of type SpriteSheet. We can call the name of the variable SpriteSheet as well. And let me catch some spelling on that. I believe there's a P in SpriteSheet. The collection is going to be our SpriteSheets list. Now inside of here, we're going to make calls to the individual setTexture methods of all of the sprites that we find. So as we're going through here, each SpriteSheet we will call setTexture. Texture needs two things, a texture 2D and the graphics device. We have the graphics device that's been passed in, but for the texture 2D, we need to grab that from the content manager. So I'm going to break this out onto multiple lines just so that it's a little bit easier to read, because we now need to make a call to that content manager. We need to tell it to load. The type of asset is going to be a texture 2D, and the asset name is going to be given by this this instance of SpriteSheet. So that is SpriteSheet. Of course, SpriteSheet holds asset name, and that is what is resolved through the content manager to gain a texture 2D. So that is the first parameter to setTexture. I'm going to jump down to a new line for the second one, and this is where we'll simply pass through the graphics device. So that finishes off the call to setTexture for the SpriteSheet, and we can terminate that line, and that should take care of our load content loop.
Fantastic.
Let me build and make sure that we have not introduced any more syntax errors. Everything builds just fine. And that is all of the code in place for the SpriteSheet class. Just a very quick recap. Again, we declared an enumeration so that we can track normal versus no damage texture sprites. Inside of Sprite, we have a set of fields to represent state. We have a set of public properties to give read-only access to useful fields. We give a few additional constructors to allow more convenience when making sprite sheets, and we set up a scenario where all sprite sheet instances can be managed and all can be loaded from one single load content call, which will result in the content manager being used in conjunction with the given asset name for each sprite to give an actual texture, which is then set for the sprite sheet.
But most importantly, we've written our first class for Space Fighter. So with that should bring this video to a close, and then we'll move into creating the actual sprite class itself. Thanks a lot, guys.